Hello everyone, thank you so much for taking time watching our video. So this is our project from the subject called Embedded System, and our aim is build successfully U-boot for the BeagleBone flag. So our team have two members. The first one will be Trần Lý Trừ Vi and the other one is Nguyễn Tấn Phúc. So now let's move on. In this video, we're just showing you guys some information, also the process that we are building the cost 2 inches with U-boot for the BeagleBone flag. Cost 2 inches is a versatile and open source toolchain generator that enables developers to build customized toolchains to different platforms and architectures. With cost 2 inches, you have full control over the build process, allow you to optimize the toolchains and tailor it to your specific project requirement. And today is it by far the most convenient way to create a standalone cross toolchain from scratch. So do we need to use this cost 2 inches at toolchain development? So according to their benefit, like flexibilities, the cost 2 inches provide a flexible and customizable framework for building toolchains, giving you a freedom to choose the component you need and its efficiency by optimizing your toolchains with the cost 2 inches, and you can achieve the better performance and reduce resource usage, resulting in faster and more efficient development. And at last but not least is portabilities, and cost 2 inches enable you to create the toolchains that can be used on the different platforms and architectures, making your cost profitable and efficiency. There are things that you must be noticed, that making sure that you have installed the required dependencies and have a working development environment before getting started with the cost 2 inches, and then obtain the latest version of cost 2 inches from the official website and follow the instruction for your operating system. So at this stage, if you have already clearly understand about the toolchains, so let's move on. This is how we install the cost 2 inches. This table will later help in vary the menu config of the cost 2 inches. to initiate the build process and let the cost-to-entry compile and assemble the components of the two chains, we will run the following command. After the cost-to-entry compilation finished, we will do the following step to test if we build the cost-to-entry successful or not. In this project, we're gonna execute this binary from our x86 host, so that's why we will install the QEMU user emulators, which just emulate the target instruction set, not an entire system with devices. This slide appears. This means that we have compiled our first ARM program with the two chains that created ourselves. So let's move on to the next sessions. What we have here is a bootloader. With your boot is an open source bootloader widely used in embedded systems, and it provides a reliable and flexible solution for building operating systems on a variety of hardware platforms. As the bootloader is the first piece of software executed by a hardware platform, the installations produced of the bootloader is very specific to the hardware platform. There are usually two cases. The processor offers nothing to ease the installations of the bootloader, in which case the GTAG has to use the initialized flash shortcut and write the bootloader code to flash. Detailed knowledge of the hardware is of course required to perform the operations, and the other is that the processor offers a monitor implemented in from and through which access to the memories is made easier. The AM33 classified a SOC on the BeagleBone falls into the second category, and the monitor integrated in the ground reads the SD card to search for a valid bootloader. So to compiling your boot and SBL, we will follow the script below. In this case, we have to use a micro SD card in order to flash the U-boot onto the BeagleBone flag. So we'll repair it and then we'll copy all the SVL and U-boot to card. This is showing that we have successfully copied all the file to the SD card, and next we will plug it into the BeagleBone flag and booting it. After connect successful with the host, you must press and hold the boot switch buttons, which is nearest to the micro SD slot on the BeagleBone flag. Power up the board using the essential 5V voltage power connector and then release the buttons after 5 seconds, and there's some output followed by the U-boot mode on the serial console. here is the debut that we will get if we are voting successfully. So this is the end of the video. Thank you so much for taking your time watching it.